It was a time of deep uncertainty and palpable fear. The year was 1962 and the Cold War had locked the world in an ideological battle between two superpowers, each armed with nuclear weapons powerful enough to destroy the planet many times over. The United States and the Soviet Union weren't just competing for dominance on Earth, they were reaching for the stars. Space was the new frontier, and whoever controlled it would have the ultimate strategic advantage. But in their fervor to push the boundaries of power and science, they overlooked one crucial truth: nature doesn't always cooperate. What began as a bold experiment to test the limits of nuclear technology quickly spiraled into a long-lasting problem, one that would reveal humanity's profound ability to alter the cosmos itself. Ever wondered what's up there that we can't see? I'm Umbra, and I'll reveal it all. Keep watching. The operation was called Starfish Prime, a name that sounded almost innocent, like the title of a sci-fi novel. But the reality was anything but. The plan was audacious. Detonate a 1.4 megaton nuclear bomb in space, far above the Earth's surface, to study its effects on the atmosphere, near-space environment, and the magnetic field. The military rationale was simple: understand how nuclear weapons function in space and assess their potential as tools for defense or offense. Yet, the true implications of this experiment were far beyond what anyone at the time could have anticipated. The night of July 9, 1962 was clear and calm over Johnston Atoll, a small island in the Pacific Ocean that had been converted into a launch site for the test. On the ground, a team of scientists and military officials nervously monitored the countdown. At exactly 9:00 p.m. local time, a Thor missile roared into the night sky, carrying its deadly payload. The missile climbed higher and higher until it reached an altitude of 250 miles, well beyond the edge of the atmosphere and into the vacuum of space. Then, with a blinding flash, the bomb detonated. For a brief moment, it was as if a second sun had appeared in the sky. The explosion unleashed a burst of energy so powerful that it could be seen from thousands of miles away. People as far away as New Zealand witnessed the night sky light up with shimmering bands of red, green, and blue. To the untrained eye, it might have looked like a natural aurora borealis, but this was no act of nature. The colors were the result of charged particles from the explosion interacting with Earth's magnetic field. It was a spectacle unlike anything humanity had ever seen, and one that came at a cost. Unbeknownst to those marveling at the sight, the detonation had created a new and dangerous phenomenon. The explosion released a massive cloud of high-energy electrons, which became trapped in Earth's magnetic field. These particles formed an artificial radiation belt, an unintended addition to the natural Van Allen belts that already encircle the planet. While the Van Allen belts are a product of nature, shielding the Earth from harmful solar radiation, this new belt was entirely human-made and far more dangerous. The effects of this radiation belt were immediate and catastrophic. Within days of the explosion, satellites began to fail. Telstar 1, a groundbreaking communications satellite that had been launched just hours before the Starfish Prime test, was among the first casualties. Its sensitive electronics were bombarded by the high-energy particles, causing irreparable damage. Other satellites met similar fates, their systems overwhelmed by the intense radiation. For a space race that was still in its infancy, this was a significant setback. Satellites represented the cutting edge of technology, the pride of both nations and scientists. Their loss was more than just a financial blow, it was a stark reminder of how fragile our ventures into space truly were. As scientists scrambled to assess the damage, they began to realize the full scope of what had happened. The artificial radiation belt wasn't dissipating as quickly as they had hoped. Instead, it lingered, a ghostly band of energy that encircled the Earth and posed a significant threat to future space missions. This was a time when space exploration was just beginning, and every mission was fraught with risks. The Apollo program, which aimed to land humans on the moon, was already facing enormous technical and logistical challenges. Now, it had to contend with the added danger of passing through this hazardous zone of radiation. The Starfish Prime experiment also revealed a phenomenon that few had anticipated: the power of an electromagnetic pulse, EMP. When the bomb detonated, it unleashed a burst of electromagnetic energy that traveled far beyond the test site. In Hawaii, over 1,000 miles from the detonation, streetlights failed, electrical systems short-circuited, and radio communications were disrupted. For the people living on the islands, it was a surreal experience. One moment, everything was normal, and the next, the lights were out, and devices were malfunctioning. For scientists and military officials, it was a revelation. The EMP demonstrated that a nuclear explosion in space could disrupt electronic systems over vast distances, potentially rendering entire regions powerless. This discovery had profound implications. The Cold War was as much a battle of technology as it was a battle of ideologies, and the idea of weaponizing space was gaining traction. The Starfish Prime test inadvertently showed how a single nuclear explosion could be used to disable satellites, disrupt communications, and even black out cities. It was a chilling reminder of the destructive potential of nuclear weapons and a glimpse into the future of space-based warfare. But the problems created by Starfish Prime weren't limited to the military or scientific communities. The experiment highlighted a broader issue: humanity's capacity to alter the environment on a planetary scale. Decades before the concept of climate change entered the public consciousness, Starfish Prime offered a stark warning about the unintended consequences of human activity. By creating an artificial radiation belt, the experiment disrupted the delicate balance of Earth's near-space environment. It was a reminder that our actions, no matter how far removed from the surface of the Earth, could have far-reaching consequences. Over time, the artificial radiation belt began to decay, but the legacy of Starfish Prime didn't fade. The experiment fundamentally changed the way we think about space exploration and nuclear weapons. It led to the realization that space is not an infinite, untouchable void. It is a fragile environment that must be protected. In 1967, just a few years after the Starfish Prime test, the Outer Space Treaty was signed. This international agreement prohibited the placement of nuclear weapons in orbit and established guidelines for the peaceful use of space. While the treaty was a significant step forward, it was not a panacea. The risks revealed by Starfish Prime remain, and the experiment serves as a cautionary tale for future generations. Today, the story of Starfish Prime is more relevant than ever. The space environment has become increasingly crowded, with thousands of satellites orbiting the Earth and more being launched every year. These satellites are critical to modern life, providing services ranging from GPS navigation to weather forecasting to global communications. But this reliance on space-based technology also makes us vulnerable. A single nuclear explosion in space, whether intentional or accidental, could cripple entire satellite constellations, plunging the world into chaos. The global economy, which depends heavily on interconnected systems, would grind to a halt, and the impact on daily life would be catastrophic. The growing involvement of private companies in space exploration adds another layer of complexity. Companies like SpaceX, Blue Origin, and others are pushing the boundaries of what's possible, launching massive satellite networks and planning missions to other planets. While these advancements are exciting, they also raise new questions about responsibility and regulation. How do we ensure that these ventures are conducted responsibly? What safeguards can we put in place to prevent accidents or conflicts? The lessons of Starfish Prime provide a starting point, but the challenges of modern space exploration require new solutions. Despite its flaws, the Starfish Prime experiment demonstrated the power of scientific inquiry to illuminate the unknown. It pushed the boundaries of human knowledge and revealed the complexities of our relationship with space, but it also showed the importance of humility and caution. Space is a shared resource, a fragile frontier that requires careful stewardship. The choices we make today will shape the future of space exploration, for better or worse. As we look to the stars, the story of Starfish Prime serves as both a warning and an inspiration. It is a tale of ambition, discovery, and unintended consequences, a reminder of humanity's ability to dream big and to make mistakes on an equally grand scale. The big problem that happened after we nuked space wasn't just about radiation belts or failing satellites. It was about the realization that our actions have the power to alter the cosmos. The question now is, what will we do with that knowledge? Will we learn from our past, or are we destined to repeat it? Only time will tell, but one thing is certain: the legacy of Starfish Prime is far from over.